After suspending every virtual warehouse over a holiday week, the Snowflake invoice was nearly identical to a normal week. Turns out, pausing compute doesn't pause storage costs. But before we unpack that incident, let's quickly cover what Snowflake is and why it's a game changer for analytics. You connect through the Snowflake web interface or a client tool. That request reaches the services layer, which handles authentication, metadata, and query optimization. Virtual warehouses then execute your SQL independently, while cloud storage keeps all your table data in compressed columnar format. The services layer handles authentication, metadata, and query optimization. Virtual warehouses are independent compute clusters that run your queries. Cloud storage keeps everything in compressed columnar format. And thanks to Snowflake's shared data model, multiple virtual warehouses can access that same data without duplication. You can check the status of your virtual warehouses with a simple SQL command. This helps you monitor which warehouses are running and how many queries they're executing. This command shows all warehouses in your account, their current state, size, and active query count. To start using Snowflake, you first open the Snowflake web UI, then set up a virtual warehouse for compute, a database and schema to organize your data, and tables using standard SQL to store it. Here we create a small warehouse that auto-suspends after 5 minutes of inactivity, a database, a schema, and an employees table with common fields. Loading data into Snowflake typically involves creating a file format, a stage that points to your files, and then using the copy into command to load the data into a table. Once loaded, it's immediately ready to query. This example shows loading a CSV file from Simple Storage Service. The file format defines the CSV structure, the stage points to the location, and copy into loads the data, continuing on errors. A SQL query is executed by a virtual warehouse with full ANSI SQL support, running directly against cloud storage, including semi-structured data stored as variant, and returns a result set that's automatically optimized, with no manual indexing required. These queries show aggregation, window functions, and semi-structured data access using the variant type and path expressions. Starting from your current table, time travel lets you query data as it existed at any point in the last 90 days, using AT or before clauses in your queries to access that historical snapshot, while zero-copy cloning creates instant copies without duplicating storage. These are powerful for recovery and testing. Here we use DATEADD to query data from 1 hour ago, undrop a table, and create a zero-copy clone of a schema for development. Starting from a slow query, Snowflake automates many optimizations, but you can further improve performance by sizing warehouses appropriately, defining clustering keys, using materialized views, and taking advantage of result caching. These commands create a clustering key on department for faster filtering, a materialized view for pre-aggregated averages, and a query using clustering information to check clustering depth. Here is exactly why that happened. Snowflake bills storage and compute separately. Suspending warehouses stops compute credits, but storage keeps accruing cost. Time travel's retention window kept historical row versions around, and the 7-day fail-safe copy sat on top of that, both billed independent of whether any warehouse was running. Result: the invoice stayed nearly identical to the prior month despite zero compute usage. The fix was to audit storage costs separately using account usage storage usage, right-size time travel retention periods on large tables, and stop assuming warehouse suspension controlled the whole bill. So storage and compute are now billed and monitored independently, with no more surprise charges on the invoice. This is the incident we just covered. Pausing a warehouse only stops compute billing, time travel, and fail-safe retention keep accruing storage charges. The fix is to also reduce time travel retention on large tables, such as setting data retention time INDAYS to 1, which cuts the ongoing storage footprint. Using select retrieves all columns, forcing a full column scan across every micropartition and inflating scan time and cost. Instead, specify only the columns you need, like employee ID, first name, last name, to avoid that overhead and reduce cost. For tables over 1 TB, not defining clustering keys, like this create table without cluster by, forces a full scan of all micropartitions on range predicates. To fix it, add a clustering key with alter table. Cluster by on frequently filtered columns, such as date, ID here. That way, the optimizer can prune partitions and skip irrelevant data. Use these commands to debug common issues. Check query history, resize warehouses, review metering, enable auto-suspend, and use time travel to recover data. First, what is Snowflake's architecture? It's a multi-cluster shared data model with separate storage and compute. Second, explain zero-copy cloning and time travel. These let you create instant copies without duplicating data and query historical data within the retention period. Third, how do you optimize a slow query? Examine the query profile, resize the warehouse, add clustering keys, and use materialized views. How is Snowflake different from traditional warehouses? It's cloud-native, separates storage from compute, and needs no indexing. Can Snowflake handle semi-structured data? Yes, through the variant type and SQL path expressions. And how do you control costs? Use resource monitors, enable auto-suspend, choose the right warehouse size, and monitor spending with account usage. To recap, Snowflake decouples storage from compute, auto-suspend keeps idle warehouses from burning credits, zero-copy cloning and time travel give you instant copies and historical recovery, and clustering keys plus materialized views keep large tables fast. Use these together to control cost and performance. Ready to go deeper? In our next chapter, we'll cover getting started, including your account setup, navigating the web UI, and running your first queries. After that, we'll dive into databases, schemas, tables, and data types. Then we'll explore virtual warehouses, compute resources, sizing, and autoscaling. And finally, data loading, stages, copy into, and file formats. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.